Scott Hinson's going to talk about swimming.
Yes.
Yeah, swimming on the moon, as the joke is going. So here we go. Passive versus active crossover is why one is wrong and why one is completely correct.
That's right.
No.
That's right. That's right. All right, everybody.
Here we go.
Here we go. Can you hear me? All right. Whoa, I'm out. No, we don't want to go forward yet. Hi, I am Scott Hinson, and today I am going to give the ultimate 100% correct guide to active versus passive crossovers. There will be nothing anyone can argue with it. And the backstory behind all of this is in 2014, Doug Self came out to Burning Amp and gave a presentation on active crossovers, and he had a list of 22 things that were a disadvantage for active crossovers. And I saw that video not long afterwards, and I held an 11-year grudge. Okay, so this tells you a few things about me. Number one, I am that petty. Number two, my memory used to be that good. Introduction, the basic way to choose passive or active crossovers, and then into some more information. So here, if you want to get in further touch, why are we still going fast? Yeah, no clickies. Okay, hold on, I'm hanging. Okay, all right. If you need to get in touch with me, here, facebook.com, DIYRM, or I don't have it on here, but my email is srhinson@gmail.com. You feel free to send me an email. I have like 80 articles and well over 2,000 pages. I've been asked a number of times, when am I coming out with a book? And that is, it's in the works. It's just, it does take some time to put together a book. And so the book is actually going to draw from a bunch of these papers, but the idea is that I'll add some filler material, because this is, a lot of times when I do one of these papers, it is because somebody has posted something wrong in a forum, and I am trying, again, I am that petty, and I am trying to prove them wrong, and then I write it up. And so these don't necessarily have a start and a finish or coherent. Each one is sort of in and of itself whole and talks about a subject. I also have a bunch of completed speaker designs for folks to build there as well. All right, so how do you choose between active and passive crossovers? If you want to go active, go active. If you want to go passive, go passive. If you can. The end. All right, we've made up the time. No. Just kidding. For real, though, there are many purported advantages and disadvantages, and I see these things posted all of the time online. Most of them don't hold up to intense study, okay? When you really dig into the issue, it doesn't, the purported advantage or disadvantage doesn't hold up, okay? So advantages that don't hold up as far as I'm concerned. Higher order crossovers improve power handling. Not really true, and there's one case it's especially not true, okay? I'll get into that in a second. Lower losses in the crossover. Nope. Most of your attenuation in a crossover is from an inductive element or a capacitive element. And the inductive portion and the capacitive portion can't dissipate power. All right. Correction of the response for each driver is simpler. No, not these days. I'll get into that in a second. Drivers of different sensitivities can be used. I do that all the time. I have used 108 dB sensitive horn tweeters with 85 dB sensitive woofers. Works great, okay? Active crossovers are essentially distortion free, and this is literally, again, I am that petty, and I love Doug Self. Like, he's not here to defend himself. He does great work, but unlike passives, this is literally how he wrote it up. If you have a passive crossover that is distorting more than your speaker, you have gone to a very high power speaker. Very high power speaker, okay? Active filters have stable values. So do passive filters. That inductor and that capacitor are not changing in value much, okay? The woofer might, the tweeter might change its impedance, but I'll show you how much that adds up later. Active filter components will not change. These sort of go together, and I don't know why he wrote them separately, but I copied it. And then smaller values for caps and inductors to save costs. I'll get into that at the end. Okay. So I stole this slide from a previous presentation. I didn't have time to rename it. Sorry about that. When you buy a dome tweeter, very often that spec sheet says, this is a 100-watt dome tweeter. No, it is not. Okay? If you put 100 watts into that tweeter, it will launch on fire faster than you can hit the volume control. Okay? I have done this. I built myself a box that measured real power into a driver, and I played pink noise at the time. M noise wasn't common. I would use M noise if I did this again. And I played M noise or pink noise into it at a real power level, real actual thermal dissipation of 5 watts in that tweeter. And I basically evaporated all the ferrofluid out of it. Okay? And the tweeter impedance was never the same. Okay? When I did it at 10 watts, the tweeter lasted a shockingly long period of time, a good 10, 12 minutes, before it stopped making its sounds. And when I did it at 20 watts, it literally caught on fire. It was a soft dome tweeter. And I bought 3 $10 tweeters to sacrifice for this experiment. But at 20 watts or so, I was, about 10 minutes later, go out, right? So the thing is that you should not be applying a named voltage function onto a driver in your crossover, because the driver has its own frequency response. And if you apply a Butterworth or a Linkwitz-Riley named filter on that, those two frequency responses add up, and you don't get what frequency response you want out of the speaker. So again, if I played at 23.83 volts, nominally 100 watts, and I had an honest-to-God Linkwitz-Riley 4th order electrical crossover, the tweeter with pink noise gets 18.6 watts. It would still burn up. Okay? Here's the kicker. Linkwitz-Riley 8th order crossover, 20.7 watts. Higher order, more power. That's that special case that I was talking about. Okay? But if I use the real filter functions of a real speaker, and these are 2 of my designs that you can get for free on my website or on the Facebook page, and I used the actual voltage transfer function of those filters, your 100-watt continuous pink noise into that speaker yields about 4.5 or 5.2 watts to those tweeters. Lo and behold, that tweeter would most likely survive-ish. Okay? Because these speakers are never meant for that length of duration of sound, right? And that's because the electrical filters for this don't look anything like these named ones. These named ones come from communications systems largely, except for Linkwitz-Riley, which comes from the speaker world. But these all come from mathematical poles and zeros. And really, I don't use these. Like, I never apply this. I'm doing something else to yield an acoustic transfer function that I want. I don't care what the electrical transfer function is, as long as it's reasonable and gets me the acoustical transfer function that I want, okay? But in the real world, you're only going to see these tweeters handle a small amount of power, okay? So that's why I'm saying when he says high order crossovers have better power handling, I mean, strictly that's true, but in practice, you get more than good enough power handling from a real crossover than you need, all right? And here is why a Linkwitz-Riley crossover, the higher order, actually has more power. So this is 2, what did I put, 500 hertz? I think I did 500 hertz. This is 2 500 hertz high-pass filters. Red and green, sorry, I picked those colors. All of a sudden, I just realized that there's some red and green color blindness is the most common one. Sorry. And you see the higher order one stays flatter longer and then drops off. There's actually more energy in this little knee than there is all of here, because the dB scale is so brutal in terms of magnitude, right? There's more energy here than there is all of here. And in fact, you've dropped off enough down here where the tweeter excursion is dropping, and I would rather take power out of the tweeter down here or way up here, right, if I'm trying to push my crossover lower. So when I go to push a tweeter lower and lower in frequency, I'm actually aiming for a fourth order acoustical response and hoping that my electrical response is starting to filter off even higher up in frequency. Okay? So that's why I'm saying that when you want these things, this whole idea that just putting a higher filter order on it gives you more power handling, if that means that you're making that driver work lower and lower in frequency, no, it doesn't. All right? All right, lower losses in the crossover. I talked a little bit about this. The L part of the L and the C part of the C can't have loss. I loved Mark's talk before this because his description of those freebie parasitic parts that we get whenever we buy inductors and capacitors, that was a really good way to explain it. And they are free parts. Like, we get extra parts with our parts. It's just we don't want those extra parts with our parts. Okay? So the hysteresis and the DCR losses of the L can be kept fairly low. And the dissipation factor / DCR of the cap is generally quite low to begin with. So let's just look at this real fast. Okay? If I put 28.3 volts into an 8 ohm load, that's roughly 3.5 amps RMS, right? My low pass inductor on that woofer is probably in the 0.25 ohm range. That means the inductor dissipating around 3 watts. Okay? The loss for the woofer is probably 99% of that power. They're 1% or less efficient. So if I'm putting near 100 watts into that woofer, I've got 95, 99 watts of power dissipation in that box from the woofer, and then 3 to 5 watts of power dissipation in that inductor. All right? You lose voltage sensitivity, but it is not a power loss. It's just not. Okay? I have, on occasion, in all the years of doing pro sound speaker designs, gotten some burned out crossovers. Every time it has been in a system that has gone to feedback or had a high frequency oscillation. I have never seen one blown out that wasn't in one of those categories. Okay? And when I say feedback, I mean that system went rails and they couldn't get to the gain controls in time. And usually what burns out is the L pad on the tweeter, right? And those are smoked, or the capacitor on the tweeter. Those are smoked, right? I don't think I've ever seen a properly sized, I've seen some comically undersized inductors blown up, but I don't think I've ever seen a real inductor blown up. All right. So to put it in another way, if I look at DCR losses of the inductor in the frequency domain, again, I picked horrible colors, sorry, but there's 2 graphs there. You can see how close they are, right? And that is, I want to say, a ½ ohm DCR. So that's kind of a small wire inductor, right? You just don't see these kind of losses, right? That's not what I would call big loss by any means. Correction of the driver responses is complicated. This used to be true, all right? Before crossover simulation software, and years ago, I got my first one. It was DOS-based. It was called CalSod, if I remember correctly, right? You've used it? Oh, yeah. Okay, yeah. It was a hand spice-like input thing. You were basically writing programming, scripting to just enter everything. It was a royal pain in the butt, but it was available and it worked. These days, this is the Vitoxcad, I'm not sure how that's pronounced, optimizer screen. You put in your crossover, you put in your topology the way you think you're going to have it, and there's an optimizer. You click optimize, and sometimes it goes off into the weeds and does something you don't want it to do, so you go back and you start it from new values and you do it again, and sometimes it just optimizes it for you, and you're done. Okay? And the deal is that if you're using a driver that is so wild in frequency response that you have to go active, that's a choice. Like a lot of times I will, like when somebody comes to me and says, hey, I want to use these magnesium cone Seos, I'm like, okay, do know that there is a possible, depending on how flat you want this thing to be and how inaudible that cone resonance you want to be, I may have to go active. They go, okay, maybe not. And say, well, definitely want to be passive. And it's like, okay, then we may want to look at an alternate woofer in case I can't make this work, right? But that's a choice. For cone materials that are better behaved than the magnesium bell, and I love those woofers. I mean, I think they sound great. This is not a criticism, it's just hard, cold truth. Real talk, that's a magnesium bell, right? It rings like crazy. But if you're choosing any other woofer, I really haven't, with those optimizers, I really haven't had trouble killing any of those breakup modes that I want to. It's so much easier these days. All right, driver sensitivities. As long as your woofer is setting your sensitivity for your system, this isn't an issue. All right, it's just not. As long as the woofer is the the lowest sensitivity item, and you're damping your mids and tweeters down to your woofer level, and 99% of the time that's the case, because you need to be damped down, you need to be dropped down to the free space sensitivity of the woofer, which is generally pretty low. I don't worry about it. Again, I've done this to extremes. I've used, 6-inch hi-fi. I use air quotes because you can use them for pro sound if you want, if they hold together, and compression tweeters on horns together, and it sounds great. It's a great system. In fact, I love those speakers because that tweeter is so coasting that you can never get it to act up. You can never get it to bark at you, and if you do, you've gone deaf and you've blown the woofer right out of the box, right? But I just don't worry about driver sensitivities. Okay, powered L pads are cheap. 2 resistors. Okay, 2 resistors, and power dissipation in a tweeter L pad is minuscule. Again, I've never seen a burned out one unless it was a feedback situation, and that means that those amplifiers are hard clipping, just rail to rail, bam, 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 spending no time in the middle, and you're sending the, double the RMS power of the amplifier into your tweeter L pad, which is what you're doing at that point. In music, this is AES75, otherwise known as M noise. It's this dashed curve. Your power density starts dropping. This is a phenomenal test signal for those that haven't used it before. Your power density starts dropping, and you just don't have that much power dissipation in the tweeter anyway. That's why that tweeter that is permanently damaged at 5 watts can be used in a system rated for 100, 150, 200 watts. All right. Remember that chart I showed where that little bit of area in the dB scale for the Linkwitz-Riley, right? Well, think about how much area this is. that was over half an octave at the corner frequency of the crossover. This is starting at 500 hertz, so 1,000 hertz 1 octave, 2,002, 4, 3, 4, 5 octaves of dropping power in that spectra for music. The dynamic range is higher up there. And when you listen to that noise, it kind of sounds like pink noise with extra popcorn in it, right? Extra pop, pop, pop sounds because the dynamic range has to be high, but the continuous long-term power is actually quite low. I don't remember. It says it in their paper. That's 10. It's actually 10 dB over 5 octaves. So Yeah. Crossover distortion. Properly sized laminate core inductors are an order of magnitude or lower in distortion than the drivers. Okay? The resistors and capacitors, they've got to be garbage if they're within multiple orders of magnitude of the driver. Okay? I have tested bipolar electrolytic capacitors for distortion, and you can do it, but they're pretty low, right? If you've ever measured the distortion of a tweeter at any real power level, it's multiple orders of magnitude higher. So if your cap is at 0.001% and your tweeter is at 0.7%, which one's going to dominate? Okay, and that's the numbers we're talking about here. Here's the example that I did. So this is 10 volts RMS of multi-tone signal, 26 volt peak, okay? The top graph, the bluish one here, so we've gone blue-green colorblind for those folks. This plot, the purplish one, bluish one here, is a resistive load. The green one is the intermodulation products, the added little intermodulation products for a 500 watt ERS Super Q laminate core inductor. Now this is a good one, right? This is a really good inductor, okay? So it is more than you see coming off the amplifier, but when I run that same signal, and by the way, this is a god-awful sound. When you listen to this sound, it wants to make you run from the rooms. This is a torture device, this sound. I put that same sound through, or that same signal through a B&C, what did I put it? 8 NDL51. That's actually a very low distortion woofer. Neodymium magnet, shorting rings, FEA optimized magnetic field, FEA optimized compliance, the works. I mean, we're talking a motor structure that has distortion reduction mechanisms similar to the ScanSpeak SD1 motor and the really, really nice JBL motors back in the day, right? The intermodulation products from the driver are 30 dB higher than the inductor. Okay? So, and that volume level, that was so freaking loud you would not use that in a residential setting. You would get to that volume level in a pro sound setting, but you would never use that in a residential setting. You'd go deaf as a post. Okay? Stable values. So I took an 8-inch two-way speaker, okay, 8-inch woofer, 1-inch tweeter, and I put 6 watts or so RMS into it. Or I shouldn't say 6 watts RMS. There's no such thing as watts RMS. Watts continuous. 6 watts continuous into it. If things were heating up so much, and this is pink noise, you would see the power dissipation drop because the impedance would be going up on all the things that were heating, right? And you would measure a very different frequency response from the system. So this happened to be a Friday night. I remember doing this vividly because my wife is like, what the hell? I was like, somebody's wrong about speakers on the internet. And I went to the garage to prove them wrong. I am that petty. And I poured, and I mean, just an 8-inch, 1-inch, I mean, this is a speaker system with a sensitivity of like 87 dB, 2.83 volts. It was loud. Like this is loud for 6 watts continuous because your peak is 12 dB more than that, right? And the power dissipation is rock solid, right? This is the real power, the blue line here, this bottom one. What you would see is you'd see the power dropping, the current dropping, and the voltage staying the same. That's what I'm measuring there. And I very quickly, after putting all that power into that speaker, measured the frequency response. These are the two measurements. That's the total sum difference. And that was, I could not be in that room without hearing protection on. Question? That was half an hour.
No, I mean, bipolar caps are notorious. And if they start off 10 microfarads on day one, by year one, they might be 7.5.
Oh, they don't go that fast. They do not go that fast. Yeah, but so the long term, I have measured 35-year-old bipolar caps out of speakers. If they don't have voltage on them all the time, they tend to be pretty good. Like I've measured many that still meet their original specs. If they are a power supply cap that has been under constant voltage at temperature in a cabinet that has gotten hot, then I have measured plenty that have died after 10, 20 years. But I see your point on stability. It's super long term, like aging type stability. There is some of that, but a film cap or an inductor, no, they're not aging. Yeah.
What about the tolerance issue on the electrolytics?
Well, I mean,
You can't get, that I know of, you can't get plus or minus 5%.
no, they're typically the bipolars are plus or minus 10%. So then a lot of folks I've trimmed, they'll put a cap. It's not truly a bypass cap because that doesn't work at these frequencies. That just doesn't. Like the leads are too long. That self-resonance, again, that Mark talked about, I think I talked about this last year, that self-resonance kicks in, and that bypass cap of 0.1 or 0.01 microfarads that you're putting in parallel with that 20 microfarad film cap, those leads are long enough, it doesn't do you any good whatsoever. Okay. All right. Crossover costs. I just released a design about a year and a half ago. SB Sinar Baja came to me and asked me to do a design with their Satori coax. And if I had unlimited budget to ship these 90-pound speakers all over each, 90 pounds each, I would have brought them out here this year because they're amazing speakers. I put a 12-inch woofer and their 7-inch coaxial driver, and I made basically a triax out of it. It's a really cool thing. And I totaled up the crossover parts, and retail crossover, it's about $300. And that has 6 millihenry 18-gauge laminate core inductors in it. Okay. If I had done that as an active speaker, 2 channels of amplification are sunk cost anyway, right? So I need 4 more channels of amplification plus DSP, and am I really going to get that for $300? If you're a large-scale manufacturer, or you're really good at buying the used cheap stuff off eBay, yes, right? But it depends on the amplifiers you want to go. Tom?
Remember, you're talking to an audience that has an average of 7 amplifiers and are joined.
I mean, I know. I know. I mean, I have 40 amplifiers at home, but I have an entire closet. Class D amplifiers are starting to change this, right? Because you can get the power levels up where you really need them, and you can get that. For years, I hated using these things because their frequency stability with frequency and load impedance was never where I wanted it, and it's getting better and better. But then again, I am a huge fan of, like my personal amplifiers when I'm running passive right now are Macintosh 2100s that I bridge mono. So I've got a 500 volt ampere transformer for a 200 watt amplifier. I mean, it's, I will admittedly say I skew that direction, right? But I really don't see that this cost is always as cut and dry of a choice. Now, if you are a global manufacturer and you can go to a factory somewhere in the world that already has a library and a skill set of parts, you may be able to get this amplifier that costs this DIY crowd, right? $500-600. You may be getting that amplifier for $100-150. Okay, that changes the scale of things, right? But then again, they're buying 10,000 of them, or committing to buy 10,000 of them at one time. Okay, here's some things that might be real and need some context. drive unit distortion may be reduced, and these were all things that Doug had in his thing, may be reduced by direct connection. This one I actually, I meant to contact Andrew Jones and ask him a couple of things. I can make a case that if you're doing a voltage drive, this isn't true. I can make a case that if you're doing a current drive, that you can actually reduce some of the hysteresis distortion in the motor with current drive. So this direct drive unit distortion with direct connection, if it's a current drive, I buy that, okay? Again, their multi-channel amplifiers are becoming more and more economical. This one is pretty real. Overload protection is easily tailored to each drive unit, okay? In a residential setting, nobody does overload protection anyway, right? So for home speakers, nobody does overload protection anyway. It doesn't matter. Voice coil heating will not affect crossover operation. Again, go back to that previous slide that I showed. That 6 watts pink noise, that was super loud, and voice coil heating didn't. This is theoretically possible, but I would have to make up a contrived test to make it show it be quite audible, right? Drive unit production tolerances can be trimmed out. Easier, but in many cases, when I see the passive systems, they might have a bucket that is, okay, do we need to put a 4.7 or a 4.5 microfarad cap into this speaker? Do a quick sweep and they can tell which one they need to prevent. So you can do that in a production setting with passive crossovers. It's just easier because it's a potentiometer typically or a DSP setting in an active setting. No inductor to inductor coupling. This is one that I wish I had had more time to do because I've done this test and I need to do a video on this because this does not do well for a write-up. Years ago, I convinced myself that this was not as much of a problem as the audiophile press makes it out to be. And this is how I did it. I had a two-way speaker that I was working on for somebody on the bench. Crossover was already separate. What I did is I disconnected the tweeter crossover and I shorted out the input to the tweeter. Okay, crossover. Not the tweeter itself, but the tweeter crossover. So now that is giving me the impedance that you see with an amplifier, because that amplifier is going to be a short circuit, right? It's a voltage source. Then I replaced the woofer with an 8 ohm resistor. And then I played pink noise into the woofer crossover until I heard sound coming out of the tweeter. Okay? And the coupling mechanism was between the inductor of the woofer low pass and the tweeter high pass. Okay? Because the tweeter crossover has shorted out, and there's no sound can be played out of the resistor, right? And I just kept cranking up the sound until I heard sound coming out of the tweeter. Shut everything off, reconnected the woofer, reconnected the tweeter, and saw how loud I was playing it. And I blew up the tweeter instantly. Well, I mean, they didn't know it was a tweeter I could buy from Matasound, so I just ordered another one. They didn't have to know. Okay? And I went, all right. The coupling, there's something called precedence effect, right? There's masking and precedence for your ears. And when you look at those curves, you'd be shocked at what can hide, okay? And I mean, like literally, if you have audible coupling of your inductors, you have zip-tied them together in the worst possible operation. And even then, I'm not sure, okay? And I wish, and I mean, I used to go to the trouble of, I'm like, well, if this inductor's like this, I got to put this inductor like this, and it's got to be at least 6 inches away, and I've got to get, I don't do any of that anymore. I just don't. So yeah, so no inductor to inductor coupling. You can get it. Where I have seen this become an issue And I luckily didn't have to chase this down. I've seen this in very high power pro sound applications, such high power that they started to set up weird resonances in the passive crossover, and they started burning out some stuff, right? But again, this was under feedback situations, and like sometimes they survived, sometimes they didn't. They could never figure out why, and that's what it was. No need for Zobel or conjugate networks with active crossovers. I haven't used a Zobel network on a tweeter in 20 years, okay? Because those optimizers allow me to get the transfer function that I want without having to flatten that impedance. I don't care. I have used a Zobel network on the upper impedance peak of a woofer if I'm trying to do a low pass close to that impedance peak, but I haven't used one on a tweeter, so this again needs context. You can get rid of them on the woofer, and that's a great place to do it. But if you're doing it because you want to get rid of it on the tweeter, that's pointless. I haven't used one of those in years. Real advantages. Clipping is confined to each band and driver. That is true. And that saves you, that saves drivers, that saves ears, that saves entire shows, right? This is the single biggest thing for me. Delays, right? Time alignment. If you need to make a delay in the analog domain, you're asking, it can be done. God, is it expensive. God, it's a pain in the ass, and you have a very limited amount you can do, okay? If I need 22 milliseconds of delay digitally, okay, 22, right? You're done. And I shouldn't say this because I like my cheap DSPs, but the install sound market regularly updates their speaker management systems, and those are great DSPs, and they're cheap. Okay, then you can do all sorts of fun, cool stuff, right? Like I've done some stuff where I know what some of my distortion mechanisms are going to be at certain levels, and I can do feed-forward error correction, distortion cancellation, and I get way more output out of these systems than people expect from small systems, right? You can actually have the amplifier measure the voice coil heating, so you know when to back stuff off. Pro sound stuff like the PowerSoft amplifiers have this internally, and so they'll monitor the impedance of the voice coil that they're attached to, and they'll know if they're going to start cooking that voice coil, and they'll start hitting the limiters for you. Like this is the coolest stuff, right? But this all brings me to the point, all the way back to the beginning, right? If I'm doing a home audio system where I don't need a delay, 99 times out of 100, I can get the result passively, right? If I'm doing a very high-powered system, typically pro, I go active. And that really is my dividing line for what I'm doing. And when you go passive on the home audio stuff, it's so much easier to set up, amp swap, all those things that you want to do, all those things you want to play with, you can without having to reset gains if it's a multi-channel system, all this stuff, right? And how many times, and I've done it, like I've been one of them. Like the first year I came to Burning Amp with my Hypex power plate amp active speakers, first thing that happened was I had set the automatic turn on too high and they weren't turning on. Now I'm like having to get out the software and reset everything. How many times have we seen that with active speakers? It's always kind of a pain to get them going, right? So you avoid all of that. But if you need this economical delay and you need a delay more than a millisecond or two, it's about the only way you're going to do it. All right. The other thing I would say with DSPs is with great power comes great responsibility. Okay. I have seen people go in there and I look at how many parametric EQ points and I'm like, you have 22 parametric EQ points on this speaker. And they're like, yes, it's great. And I'm like, okay, go get speaker number 2 off your production line. Oh, it's not near as flat anymore. That's because there's slight differences between every driver, especially up towards breakup, right? And you have tuned to that driver, not the overall shape of the curve. So with great power comes great responsibility. Do not overcorrect. All right, questions? How am I doing on time? Am I okay? Okay. Oh, okay. I see a bunch of hands shoot up. See, you guys keep inviting me back, so I keep having to do more inflammatory talks until I'm not invited back.
When you're talking about the L pads,
Mhm.
what kind of resistors do you use for that?
I just using sandcast resistors, sandcast wire rounds.
Sandcast, wire
Yeah.
round?
There's a large contingent of specialty resistor companies. I don't buy any of them. In fact, there's a number of folks that say sandcast resistors sound grainy, and then they sell other resistors. But if you ever break, and it's not sand, right? That's an epoxy, that's a ceramic epoxy, right? If you ever break that coating off, what's in there is a wire round resistor that looks just like the round tube wire resistors that they sell. It just has a different set of glue and stuff put on the outside.
I've never measured them. Is there any kind of an inductive component of those wire rounds?
You can get non-inductive Ayrton Perry winding versions of them. I've just, for reasonable values, the inductance is so low that I just don't worry about it. I mean, we're talking under 30 ohms. I've measured them to be still 30 ohms at 20 kilohertz. So I don't care. If they become 35 ohms at 60 kilohertz, okay, so the bats get the wrong crossover, right? Like, I don't care, right? Whoop, did it shut off?
Can you hear me?
Yes, I can hear you.
All right. So can you combine, like, say, a notch filter with say, a non-DSP type of electronic crossover?
A notch filter. Yes,
Like
you can mix and match. You can mix and match. In fact, Purify has an excellent white paper on this with their drivers that show that if you do a passive notch filter for the cone resonance, you actually get really good out-of-band distortion reductance even in an active system. And that's because you've essentially gotten a current drive in that section, and you're knocking out the ability of that motor to be moved by the cone resonances. It's really cool.
So given your great powers come great responsibility, I was wondering what your thoughts are on room correction, because that's usually throwing a lot of eyeballs at the room.
With great power comes great responsibility. Yeah, I tend, I don't actually use it at all in my personal system. And when I've set it up for folks, I tend to go with a very soft touch on it. You know, you can, the problem is that if you room correct and then you move those speakers at all, right?
Going back to individual components in the passive crossovers, how important is wire gauge size in air core inductors? I mean, you hear a lot of folklore about using 14 gauge, 15 gauge in the woofer circuits, and 18 and 20 in the tweeters. How concerned should I be?
I don't think I have I don't have a slide for that. So in that Vitawix CAD, or Sound Easy, which is not easy, it should be called Sound Not Very Easy. When you do these crossovers, you can put in the DCR value for the inductor. I encourage you, in fact, this is great. Somebody email me to remind me that this is a paper that I need to do, of what happens when I change DCR values, like how much does it impact? Some circuits it'll matter, okay? Usually tank circuits for LCRs that are in series with each other in parallel with a driver, then your DCR of that system matters a lot. But for just your general low pass, high pass, like people are spending an awful lot of money on 10, 12 gauge, 14 gauge air core inductors, and they really don't need to be because it really doesn't make that big of a difference. Yeah. Where it would make a difference, if it is going to make a difference, is the low pass inductor on a low impedance system. So if you've got a 4 ohm woofer or even a 2 ohm base system, then you really need to start worrying about that DCR of that low pass. But if it's an 8 ohm woofer, I mean, I have gone to the point of actually, because I know I'm having to work with a budget, gone to the point of saying, okay, I'm going to account for that DCR in my base alignment. I make my cabinet a little bit different size, and we purposely buy an air core inductor because I know it's not going to saturate, right? Not a potted core inductor that when it saturates sounds like hard amplifier clipping, and gone with a, you know, a 0.75 or a 1 ohm DCR inductor because it's cheap. And it fits in the very tiny box that they need it to fit in. Because I know they're never going to put that much power into it, and by the time they're burning up the inductor, the woofer has been crying for help for hours, right? Like it was crying for help 20 dB ago, so it doesn't matter.
Anybody else have any questions for Scott? Oh, here we go.
And it looks like one over here too.
So you were talking about the fourth order filters actually.
On the Linkwitz-Riley only.
Right, okay. So in doing a passive crossover, what order do you prefer?
I don't ever prefer an order. What I'm trying to do is get my polar response so that I have a main lobe that's pointed forward, not up or down, so we don't have to do the whole baffle tilt thing, okay? And if you get an acoustic Linkwitz-Riley fourth order on both your woofer and your tweeter, you are largely guaranteed that for reasonable geometries and reasonable directivities of drivers, okay? And so what I end up having to do is accommodating the frequency response of both the tweeter and the woofer. So it is not uncommon for me to have a second order electrical filter on the woofer to achieve a fourth order acoustical roll-off, and a third order electrical filter on the tweeter to achieve a fourth order acoustical roll-off, and a notch filter or two to knock out any resonances. And then I get a nice combination and sum. Okay, I don't care what I had to do, I just want that nice combination and sum. And I'm making this shape because I want that typical wide V of the Linkwitz-Riley, you know, double Butterworth filter, right? Yes.
Question. I have active system and I have a tweeter that's a compression driver. I often use an L-pad to burn up a few watts to get better signal noise.
That's an excellent way to do it. I do that all the time. What he's talking about when he says burn up a few watts is he's trying to passively reduce the sensitivity of that tweeter, because when you have a 108 or 110 dB sensitivity compression driver hooked up to an active system with DSP especially, if you don't have your preceding gain stages set perfectly, you can get a lot of self noise in that system very easily, some hiss that comes out that's very difficult to get rid of. On the active systems that I use, or the active system that I currently listen to, the main active system I currently listen to, I actually have a 10 ohm resistor in series and a 1 ohm resistor in parallel with a 16 ohm driver to knock the sensitivity down, because I wanted there to be no chance of hiss, right? And the fact that I'm now using, you know, the Class D amplifier module that's on that tweeter is 200 watts. The fact that I'm using, you know, 20 volt RMS signal is actually on purpose, because now I have effectively a constant 8 ohms sitting on that, so I have no amplifier output impedance issues, and I've knocked all that hiss down 20 dB. One last one. Quick.
So do you recommend using laminate core versus ferrite
Yes.
core inductors?
Laminate core inductors. I do not use ferrite core inductors anymore, ever. Even the P cores, the nice expensive Janssen P cores, and they would probably hate to hear me say that, but I don't even use those. So.
Scott Hinson, everyone.
Thank you.